Question 15. Which of these contains the greatest number of atoms? Quite a tricky question, this. First of all, they're in some of them are in milligrams and kilograms, so I'm going to have to get that into grams first of all, and then I'm going to work out number of moles, so I'm going to have to know the MR of each of these to work out the number of moles. Once I've got the number of moles, I could multiply each of them by Avogadro's number to work out the number of particles that I've got, and then if I look in each particle or molecule, I could look at the number of atoms and multiply that up. Okay, let's have a look first of all. 127 milligrams is divided by 1,000. You have to get small unit value up into a large unit value. 1.27 is 0.127 grams. And I'm just going to go through the rest now and just work it out in grams first of all. 1.54 times 10 to the minus 4 kilograms. Kilograms down into grams. Then I multiply by 1,000, so this multiplied by 1,000 is 0.154 grams. If I did the same here, milligrams divided by 1,000 to get into grams, 0.081, and here kilograms to get into grams, 1.7 times 10 to the minus 4, and multiply by 1,000 to get grams down into kilograms down into grams, 0.17. So I've now got the masses of each of these. Now I'm going to work out have a look at the molecular formula of each of these. Iodine's I2, two atoms bonding together in group 7 to fill up their outer shells with a single covalent bond. P4, 4 atoms come together, so 4 phosphorus atoms come together as P4, just something to remember. Carbon dioxide, CO2, and ammonia, NH3, so you need to remember those. Let's work out the MRs of each of those and therefore the number of moles. So moles is mass divided by MR. I2, 2 126.9s, works out as 0.0005 moles of iodine. Number of moles of P4, I've got 100, number of moles is the mass divided by the MR. The MR of P4, 4P is 123, 0.00125. CO2 is 12 added 2 16ths for the carbon and the 2 oxygens. Mass is 0.081 divided by 44, 0.0018, and the ammonia is a 14, add 3 ones for the hydrogens, 0.017 for the mass, divided by the MR of 17, 0.01. Now then, I've got the number of moles. I could multiply each of these by Avogadro's number to get the exact number of particles, but if I'm just working out the greatest number of atoms, I'm just doing the same thing through. So I'm not going to multiply by Avogadro's number each time, because you'd just be doing the same. So if I'm making a comparison of the greatest number, I'm just wasting my time here. So I'm not going to bother, but I am going to multiply by the number of atoms in each of the molecules, because it's asked for number of atoms rather than number of particles. So there's 2 I's in I2, so multiply by 2, 0.001. P4, there are 4 in P4, so multiply by 4, 0.005. Multiply by 3, because there's a carbon and 2 oxygens, 0.015. And ammonia, there's 1 N and 3 H's, 4 atoms in NH3, multiply by 4, 0.02. So the largest value, therefore, is D at 0.02 of all of the answers. 25 centimetre cube samples of sodium hydroxide were taken by pipette from a beaker. These were then titrated with aqueous solution of ethanoic acid. The concentration of the ethanoic acid calculated from the experimental results was found to be lower than the actual value. How could this explain the difference? So, the concentration of the ethanoic acid calculated from the experimental results was found to be lower than the actual value. So, concentration is moles divided by volume. Okay. If the concentration is too small, then the number of moles is too small. So concentration is moles divided by volume, and if the concentration is too low, then the number of moles is too low. Now, why could the number of moles be too low? Well, another reason the concentration could be too low is that the volume is too big, because when you divide by a big number, then the concentration would be lower. So maybe the volume is too big. This could be because the volume from the burette is too high. So there's two reasons why the concentration of ethanoic acid might be too low. Maybe there's not enough moles, or maybe the volume from the burette is too high, because if you divide by a large number, then the concentration would be smaller. So maybe the volume is too high. So here, rinsing the burette with distilled water before filling up with ethanoic acid. The water in the burette is mixed with the ethanoic acid, making it less concentrated than expected. So more would be needed to add it from the burette. So its volume would be larger. So the answer is B, because you're diluting the ethanoic acid in the burette. It's less concentrated, so you need more than you expected. Your answer is B.